Students, welcome to All Fours Maths class. Dear students, I am going to discuss the topic straight lines. This topic is very important for JEE mains and advanced. So, follow carefully. Now, coming to the topic. Straight lines. In general, straight lines are three types. In general, straight lines are three types. They are horizontal lines, vertical lines, oblique lines. That means inclined lines. The straight lines are three types: horizontal lines, vertical lines, oblique lines. What are the horizontal lines? Simply, horizontal lines are the lines which are parallel to x-axis. Already we know the coordinate system. In the coordinate system, horizontal line is said to be x-axis and vertical line is said to be y-axis. Okay. Here, the horizontal lines are nothing but x-axis and the lines which are parallel to x-axis are said to be horizontal lines. The x-axis and the lines which are parallel to x-axis are said to be horizontal lines. Similarly, vertical lines. The y-axis and the lines which are parallel to y-axis are said to be vertical lines. Next, oblique lines. The lines which are neither horizontal nor vertical are said to be oblique lines. Okay? Please note these values. In general, straight lines are three types. They are: first one, horizontal lines. The x-axis and the lines which are parallel to x-axis are called horizontal lines. Suppose this is one of the coordinate system, x dash, y dash. The point of intersection is origin. Okay. The x-axis this and the lines parallel to this x-axis. All of these are said to be horizontal lines. The x-axis and the lines which are parallel to x-axis are said to be horizontal lines. Okay. Next, second one, vertical lines. The y-axis and the lines which are parallel to y-axis are called vertical lines. Simply, it is the coordinate system, x dash, y dash, O is the origin. It is the y-axis. Y-axis and the lines which are parallel to this y-axis, all of these are said to be vertical lines. Okay. Next, oblique lines or inclined lines. The lines other than horizontal and vertical lines are said to be oblique. That means simply the lines which are neither horizontal nor vertical are said to be oblique lines. The oblique lines are in this way, neither horizontal nor vertical. That means, suppose this is the coordinate system. Horizontal lines means they are parallel to x-axis. Vertical line means they are parallel to y-axis. Oblique lines means they are some inclined with x-axis and y-axis. So, in this way, these are the oblique lines. These are oblique lines. Okay. Please note this value. Oblique lines. This is one of the oblique line. It is one of the oblique line. All of these are oblique lines. The lines which are neither horizontal nor vertical are said to be oblique lines. Okay. Next, second point. Inclination of a line. Inclination of a line. What is the inclination? Suppose this is one of the line in the 2D plane, xy plane. The angle made by the line with positive x-axis in positive direction. If the angle is measured in anti-clockwise direction, then it is said to be positive direction. If the angle is measured in clockwise direction, then it is said to be negative direction. Okay. Now, the angle of inclination is nothing but the angle made by the line with positive x-axis with positive x-axis in positive direction. That means it is the positive x-axis, it is a line. In positive direction means this value. The angle between the x-axis and this is also an angle, but this is, we take it, this direction is clockwise. That means negative direction. This is not the angle of inclination. Angle between the, angle of inclination is nothing but angle made by the line with positive x-axis in positive direction. In positive direction. This value is said to be angle of inclination. Okay, please note this value. The angle made by the line with positive x-axis in anti-clockwise direction, that is positive direction in bracket, is called inclination of the line. This can be denoted by theta. This can be denoted by theta. Here the range of theta is 0 degrees less than or equal to theta less than 180 degrees, or 0 less than or equal to theta less than pi in radians. How we find the range of this theta? Suppose this is the angle between the positive x-axis and the line. Suppose the line moves in positive x-axis, then this theta reduces. If this value coincides with x-axis, what is the value of theta? Theta is equal to 0 degrees. So the value starting from 0. Okay. Next, the line goes to in this way. Suppose the line is in this way. The angle between this and between the line and x-axis is 90 degrees. Suppose the line is in this way. The angle between the line and x-axis is more than 90. That means obtuse angle. Suppose this line moves in this way. The angle increases up to 180 degrees. Suppose the line coincides with this value, yet theta is equal to 0 degrees, the line coincides with x-axis, yet 180 degrees also, the line coincides with x-axis. Both are same. So we take only one value, 0 or 180. In standard results, we take from 0 to 180. 180 is open and 0 is closed. Next, if the line moves more than 180, then the angle between the line and positive x-axis in positive direction is nothing but this value. That means it starts from 0. So the range of this value is 0 to 180 degrees. It is very, very, very important. The range of angle of inclination is 0 to 180. 0 degrees is less than or equal to theta less than 180. Okay. Next, please note this diagram. Angle of inclination. This is the theta in positive direction. It is positive direction. Okay. Note, inclination of the horizontal line is 0 degrees. Horizontal line is nothing but x-axis of the lines which are parallel to x-axis. If the line coincides with x-axis, the theta becomes to 0. So, inclination of the horizontal line is 0 degrees. Next, inclination of the vertical line. Vertical line means it is parallel to y-axis. So, the angle between the x-axis and y-axis is 90 degrees. So, inclination of the vertical line is 90 degrees. Next, third one. It is also very, very important. If the line makes an angle pi with positive x-axis in negative direction, then angle of inclination theta is equal to 180 minus pi. Please observe this value. It is the positive x-axis. Positive x-axis. Okay, it is the positive x-axis. The angle made by the positive x-axis with the line in negative direction means this value. This angle is equal to what is the value? Pi. This value is equal to pi. But angle of inclination is equal to theta. It is the straight angle. Theta plus pi is equal to how much? 180 degrees. So, what is the value of theta? 180 minus pi. If the line makes an angle pi with positive x-axis in negative direction, then angle of inclination theta is equal to 180 minus pi. Please note this value. It is the pi. Pi plus theta is equal to 180. So, theta is equal to 180 minus pi. Okay. Next, third point. Slope of a line or gradient of a line. Slope of a line or gradient of a line. Slope is denoted by m. If the line makes an angle theta with positive x-axis in positive direction, then the value of tan theta is called slope of the line or gradient of the line. It can be denoted by m. Here, what is the value of theta? The line makes an angle theta with positive x-axis in positive direction. That means theta is the angle of inclination of the line. If theta is the angle of inclination of the line, then the value of tan theta is said to be slope of the line. It can be denoted by m. Therefore, slope m is equal to tan theta. Slope m is equal to tan theta. Next, for horizontal lines, what is the angle of inclination? For horizontal lines, suppose this is the x-axis, the line x-axis and the lines which are parallel to x-axis are said to be horizontal lines. What is the inclination of the horizontal lines? Theta is equal to 0 degrees. So slope m is equal to tan theta. Tan 0 means 0. So slope of horizontal lines is equal to 0. Okay. Next, what is the slope of vertical lines? The vertical line is nothing but y-axis, or the lines which are parallel to y-axis are said to be vertical lines. What is the angle of inclination in this case? Theta is equal to 90 degrees. The angle between the positive x-axis and this vertical line is 90 degrees. So slope m is equal to tan theta means tan 90. What is the value of tan 90? Infinite. That means not defined. Slope of the vertical line is not defined. Very, very important. Okay. At the same time, suppose the slope value, suppose the angle of inclination lies in between 0 to 90. If the angle of inclination lies in between 0 to 90, what is the value of slope? Slope m is equal to tan theta. That means theta lies in the first quadrant. In the first quadrant, the value of tan theta is always positive by using all silver teacups. That means slope m is always positive. If 0 less than theta less than 90, slope m is positive. If suppose 90 degrees is less than theta less than 180 degrees, that means theta is obtuse angle, it goes to second quadrant. By using the all silver teacups, tan value is negative in second quadrant. So m is equal to tan theta, this value is negative when 90 less than theta less than 180. Okay, the slope is negative when m is less than 0. Please note these points. Slope of horizontal line is 0. Since theta is equal to 0 degrees, that implies m is equal to tan theta, tan 0 means 0. Next, slope of vertical line is not defined. Since theta is equal to 90 degrees, angle of inclination is equal to 90, m is equal to tan 90, that means not defined or infinite. Not defined. Okay. Next, third one. If 0 less than or equal to theta less than 90, then slope m is positive, m greater than 0. If theta is equal to 90, then m is not defined. If 90 degrees less than theta less than 180, then m is negative, m less than 0. Please note these points. Next, fourth point. If two lines are parallel, then their slopes are equal. Suppose m1 is the slope of the first line, m2 is the slope of the second line, then m1 is equal to m2. If two lines are parallel, then their slopes are equal, that is m1 is equal to m2. Proof. Suppose L1, L2 are two lines which makes an angle theta 1, theta 2 with a x-axis. That means angle of inclination be x-axis. Now, angle of inclination be theta 1, theta 2. Okay. Let theta 1, theta 2 be angle of inclination of the lines L1, L2. If the angle of inclination is given, what is the slope? M is equal to tan theta. Slope of first line M1 is equal to tan theta 1. Slope of M2 is equal to tan theta 2. But from the given, these two lines are parallel. These two lines are parallel. These are parallel and x-axis is one of the line. This line is transversal. So these two angles must be equal. These are corresponding angles. Since L1 parallel to L2, that implies theta 1 is equal to theta 2. Applying tan on both sides, that implies tan theta 1 is equal to tan theta 2. Actually, tan theta 1 is equal to m1, tan theta 2 is equal to m2. That implies m1 is equal to m2. If the two lines are parallel, then their slopes are equal. Okay, very, very important. Please note this value. Next, fifth one. Let m1, m2 be slopes of two perpendicular oblique lines. That means inclined lines. M1, M2 be slopes of two perpendicular oblique lines. Then product of the slopes M1, M2 is equal to minus 1. Then M1, M2 is equal to minus 1. Very, very important. In this case, the two lines are perpendicular. Let theta 1, theta 2 be the angle of inclination of the two lines. Say this is one of the line, first line. Angle of inclination of this line is theta 1. Say this is second line, angle of inclination of this line is theta 2. These two lines are perpendicular. That means this angle must be 90 degrees. Okay, if the angle of inclination is given, what is the slope? M is equal tan theta. So m1 is equal to tan theta 1, m2 is equal tan theta 2. Okay, let theta 1, theta 2 be the angle of inclination of the lines L1, L2 respectively. Then m1 is equal tan theta 1, m2 is equal tan theta 2. Since the two lines are perpendicular, L1 is perpendicular to L2, that means this angle is 90 degrees. In any triangle, sum of the interior angles is equal to exterior angle. Sum of these two values is nothing but this angle. Okay, these two are interior angles, this is the exterior angle. Okay, that means 90 plus theta 1 is equal to theta 2. 90 plus theta 1 is equal to theta 2. So L1 is perpendicular to L2, that implies theta 1 plus 90 is equal to theta 2. Applying tan on both sides, we get tan of theta plus 90, tan of theta plus 90 is equal to tan theta 2. Tan 90 plus theta means second quadrant, minus cot theta 1. Minus cot theta 1 is equal to tan theta 2. What is the value of minus cot theta 2? 1 by tan theta 1. Cot is nothing but 1 by tan is equal to tan theta 2. But actually tan theta 1 is equal to value m1, tan theta 2 is equal to m2. Minus 1 by m1 is equal to m2. After cross multiplication we get m1 m2 is equal to minus 1. Very very important. If the two lines are oblique such that m1 m2 is equal to minus 1, they are perpendicular. But if the lines are horizontal and vertical, what is the angle? Horizontal line, vertical line. Angle between these two values is always 90 degrees. But in this case, the slope of this value is 0, but slope of this value is not defined. So in this case, m1, m2 is not equal to minus 1. Here m2 is not defined. Please observe these values. Okay, if the lines are horizontal and vertical, always that value is angle between the two lines is 90 degrees. But in this case, m1, m2 is not equal to minus 1. That means m2 is not defined. So we can't find that value. Okay, please note that value. Next, sixth point. If a x1 y1, b x2 y2 are any 2 points on a line, then slope of the line AB is y2 minus y1 by x2 minus x1. Slope of the line AB is y2 minus y1 by x2 minus x1. Proof. Say a x1 y1, b x2 y2 are 2 points in xy plane. Let L comma m be the projections of a comma b on x-axis. Let L be the projection of a on x-axis and m be the projection of b on x-axis. Then what is the length OL? OL is nothing but abscissa of this coordinate, that means x1. What is the value of OM? OM is nothing but abscissa of the point B, that means it is x2, this value total. Now this LM is equal to x2 minus x1. Okay, next, n be the projection of A on the line BM. Here AL is equal to, this is nothing but ordinate, that means y1. AL is equal to mn, this value is equal to y1. Next, at the same time, this value is equal to ordinate of the point B, that is y2. So Bn is equal to y2 minus y1. Please observe this value. Okay, suppose the line AB makes an angle theta with x-axis. What is the slope of the line? Slope of the line is nothing but tan theta. Now we find the value of tan theta. Okay, let theta be the angle of inclination of the line, then slope m is equal to tan theta. Now we find the value of tan theta. Please observe this value. This AN is parallel to x-axis. These two are horizontal lines. That means this line is transversal. That means this angle is theta. Automatically this value is automatically equal to theta. These two are corresponding angles. These two are corresponding angles. So from this diagram, angle BAN is equal to value theta. This angle of inclination is theta. So this value automatically theta. Now we find the value of theta. In right angle triangle, what is the value of tan? Opposite side by adjacent. So tan theta is equal to slope m is equal to tan theta. That is equal to y2 minus y1 by, what is this value? x2 minus x1. Therefore slope of this line is equal to y2 minus y1 by x2 minus x1. Please note these values. This proof, a is equal to x1 y1, b is equal to x2 y2 are given points. Let L comma m be the projections of a comma b on x-axis. Okay, and n be the projection of A on this line BM. Let the line makes an angle theta with x-axis. This line makes an angle theta with x-axis. Then automatically this angle is theta. Now we find the value of tan theta. Please note this tan theta. Next, fourth point. First one, the equation of x-axis is y is equal to 0. Please note this value. The equation of x-axis y is equal to 0. Please observe the coordinate system. This is x-axis, this is y-axis. Okay, it is the origin 0, 0. Suppose the points in the x-axis are 1, 2, 3, so on, this values. What is the corresponding point at this one? This point is 1, 0, 2, 0, 3, 0, 4, 0, so on. In this case, -1, 0, -2, 0, -3, 0. Please observe these values. On x-axis, all the y coordinates values must be 0. That is, on x-axis, the y coordinate is always 0. So, the equation of the x-axis is y is equal to 0. The equation of x-axis y is equal to 0. Since on x-axis y coordinate is always 0, so that equation is y is equal to 0. Very, very important. Similarly, on y-axis, what are the conditions? This is 1, 2, 3, so on, these values. It is 0, 1, 0, 2, 0, 3, 0, 4, so on. That means all the x coordinates must be 0. So, the equation of the y-axis is x is equal to 0. The equation of y-axis is x is equal to 0. Since on y-axis, x coordinate is always 0. Next, third one. The equation of the line parallel to x-axis and passing through the point Px1, y1 is y is equal to y1. Please observe this value. The line is parallel to x-axis. That means it is x-axis. The line is in this way, parallel to x-axis, and it passes through the point Px1, y1. What is this value? This value is nothing but y1. These two are parallel. That means the y coordinate is always constant. This distance is always constant. That means y is equal to y1. Please observe this value. The equation of the line parallel to x-axis and passing through Px1, y1 is y is equal to y1. Similarly, the equation of the line parallel to y-axis and passing through the point Px1, y1. In this case, the diagram is in this way. Parallel to y-axis means in this. It passes through Px1, y1. Okay. What is this distance? This distance is nothing but, what is this value? x1. These two are parallel. That means the distance is always constant. That means x coordinate is always constant. That is x is equal to x1. Okay. Please note this value. The equation of the line parallel to y-axis and passing to the point Px1, y1 is x is equal to x1. Okay. Next, fifth one. Equation of straight lines in different forms. Equation of straight lines in different forms. Again, first one, slope point form. In this case, the equation of the line passing through the point A x1, y1 and having the slope m is y minus y1 is equal to m into x minus x1. If the point A x1, y1 and slope m is given, then what is the equation of the line? Y minus y1 is equal to m into x minus x1. Very, very important. It is said to be slope point form. If the slope is given and point is given, then equation of the line is y minus y1 is equal to m into x minus x1. So in this case, the point on the line x1, y1 is given. Say this is one of the line. A x1, y1 is one of the point on the line and m is the slope of the line. Say Px, y is any point on the required line. Px, y is any point on the required line. Then what is the slope of the line AP? If 2 points are given, what is the slope? AB slope is equal to y2 minus y1 by x2 minus x1. By using that formula, we find the slope. But from the given slope is already given m. So m is equal to, what is the slope of this value? y2 minus y1 by x2 minus x1 means y minus y1 by x minus x1. So let Px, y be the any point on the line, then slope of the line AP is equal to y2 minus y1 by x2 minus x1. But from the given slope is m. Therefore, m is equal to y2 minus y1 by x2 minus x1. That means m is equal to y minus y1 by x minus x1. After cross multiplication, we get y minus y1 is equal to m into x minus x1. It is the required proof. Okay. Note point. If the point and slope are given, the equation of the line is y minus y1 is equal to m into x minus x1. Okay. If the line passes through the origin and the slope is m, what is the equation of the line? Here x1, y1 is equal to 0, 0. That means this value is equal to 0, this value is equal to 0. So the equation can be reduced into y minus 0 is equal to m into x minus 0. That means y is equal to mx. If the line passes through origin with the slope m and having the slope m, then its equation is y is equal to mx. Okay, please note this point. The equation of the line passing through 0, 0 and having slope m is y is equal to mx. Y is equal to mx. Next, shortcut formula. It is a shortcut formula. Please note this value. If m is equal to a by b, slope is a by b, and p is equal to x1 y1, then equation of the line is, if m is equal to a by b and p is equal to x1 y1, point p is x1 y1, then equation of the line is ax minus by is equal to ax1 minus by1. It is direct formula to find the equation of the line. Single step. Next, if m is equal to minus a by b and p is equal to x1 y1, then equation of the line is ax plus by is equal to ax1 plus by1. Please observe this value. If the slope is a by b, we take opposite sign. A means x coefficient, b means y coefficient, and we take minus sign, ax minus by. Here plus, we take minus. Here minus, we take plus, ax plus by. Please observe that value. And substitute the point x1 y1 in this equation, in this expression. ax1 minus by1, ax1 plus by1. Okay? If the slope and point are given, to find the equation of the line, we use simply these formulas. Example. Find the equation of the line passing through 1, 2 with the slope 2 by 3. With the slope 2 by 3. Actual method is slope is equal to 2 by 3 and the point p x1 y1 is equal to 1, 2. That means the equation of the line is y minus y1 is equal to m into x minus x1. If the slope and point are given, what is the equation of the line? Equation of the line is nothing but y minus y1 is equal to m into x minus x1. By substituting these values, y minus 2 is equal to 2 by 3 into x minus 1. Okay. After cross multiplication, we get 3y minus 6 is equal to 2x minus 2. That implies 2x minus 3y. Move this minus 6 to RHS, 3y to RHS. That means minus 6, it will plus 6. Okay, plus 6 minus 2 means plus 4 is equal to 0. It is the equation of the required line. By using this property, simply we find in this way. M is equal to 2 by 3. That means it is in the form of a by b. What is the equation of the line? Ax minus by is equal to ax1 minus by1. It is simple formula. 2 by 3 means the equation of the line is 2x minus 3y is equal to 2x1 minus 3y1. What is the value of x1 y1? x1 y1 is nothing but the point. The point is 1, 2. Substitute this point in this equation. What is that value? 2 into 1, 2 minus 6. That means 2 minus 6 means minus 4. So 2x minus 3y plus 4 is equal to 0. Using this formula, we find direct equation. Okay. Next, second one. 2 points form. In previous case, when slope and point are given, we find the equation of the line. That equation is y minus y1 is equal to m into x minus x1. In this case, if 2 points on the line are given, then we find the equation of the line. Please note this value, 2 points form. The equation of the line passing through a x1 y1 and b x2 y2 is y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. In this case, the 2 points on the line are given. Suppose it is the x-axis and y-axis. This is the line a x1 y1 and b x2 y2 are 2 points on the line. If 2 points on the line are given, what is the slope? Slope of that line is equal to y2 minus y1 by x2 minus x1. Here a x1 y1 b x2 y2 are 2 points on the line. We know that the slope of the line AB is y2 minus y1 by x2 minus x1. Therefore, slope of that line is y2 minus y1 by x2 minus x1. If the slope and point are given, what is the equation of the line? Y minus y1 is equal to m into x minus x1. Here slope, already we find this value y2 minus y1 by x2 minus x1. 2 points are given. That means we take any one of the point. One point is available. So the equation of the line slope point form is y minus y1 is equal to m into x minus x1. Here what is the value of m? M is equal to y2 minus y1 by x2 minus x1. Substitute this value in this equation. That means y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. That means move this y2 minus y1 to LHS. That means y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. It is the required equation of the line when 2 points are given. Okay, please note this value. Take one example. Find the equation of the line passing through the points 2, 3 and minus 5, 2. Here the first point is 2, 3, second point is minus 5, 2. If 2 points are given, what is the equation of the line? Y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. Substitute these points in this equation, we get the equation of the line. Simplify this value.